In this tutorial, we're going to take a look at the method called completing the square. And it's a method or a strategy to take a parabola that's in standard form and convert it into vertex form. Okay, so you can see what the vertex is. So I'm going to take a look at three examples, a fairly basic one on this page, and then two ones that are a little bit more complicated on the second slide. And I put the steps up here in the top right corner to complete the square. When the question is fairly basic like this, you actually can skip some of these steps, and I'll explain as we go here. So the first one says factor the a value of the terms with the variable. So the variable is the x and x squared and 10x on the right here, or the variable terms. And because, see, you don't see a number here in front of the x squared, so the a value would be 1. And if the a value is 1, then you don't have to bother try to factor 1 out of x squared plus 10x because it looks the same. Okay, so you actually get to skip this first step. And the second one says to find the value. You take the linear term coefficient, which is the 10x, so we're taking the 10, and we're going to divide it by 2 and square it. So 10 divided by 2 is 5 that we're squaring, and that's 25. And we take that value and we add it and subtract that amount at the end of the brackets. Now, there aren't any brackets in this case. This is where the brackets would, some people actually write these in, even if the a value is 1. The brackets would be here. So we're going to put that 25 at the end of the at 10x. You don't actually have to put the brackets here. And I'll get rid of my writing here. So we're going to add 25 and subtract 25 after the 10x term. Now, we only actually need the plus 25 so that this is going to be a perfect square trinomial. So when we factor it, the two factors are the same. You can't just add 25 to the parabola's value because that would change the parabola. It wouldn't be the same equation. So we subtract 25. So if you're wondering why we add and subtract 25, we add 25 so that we have a perfect square trinomial. We subtract 25 to keep the equation to have the same value or balanced. Okay, so if you add and subtract 25 to something, you actually in total or in net have actually added nothing to it. But we need the 25 here so that this is a perfect square. We subtract the 25 to keep it have the same value. So now step 3 says remove the subtracted value, which is the negative 25, from the brackets. But there aren't any brackets in this case because the a value is 1. So we don't actually have to do step 3 if the a value is 1. So when the a value is 1, you actually get to skip the first and third step. Okay. So the last step is says to factor the perfect square trinomial and combine the like terms in the end. So we're going to do this. So this trinomial right here, that's what we're factoring. We're going to put the factors in here. And negative 25 and negative 8 is negative 33. So I've combined the like terms in the end. Now, this would have to start with an x because it's x that we squared to make this x squared. Okay, and I'll explain, I'll check. I'm going to show you a check of this afterwards. What goes after the x? So this is going to be a binomial, or it's x plus something or x minus something. A couple ways where you can figure out what that number is. First of all, it's the number that we squared here to get to 25. So it's plus 5. Also, it's always half of this coefficient right directly above it. There's a 10x here, so the half of the 10 is 5. That gives you the correct sign as well. This is plus 5. So that is the completing the square step process is finished. Now I'm going to show you how to check this to make sure that your completing the square has been correct. So this is what the check would look like. X plus 5 squared means 2x plus 5 is multiplied. And don't forget there's minus 33 here. And we're going to expand this out, and we should end up with the same trinomial, or y equals x squared plus 10x minus 8 that we started with. So remember, when you're multiplying two binomials together, you multiply everything in the first by everything in the second. So x times x is this x squared, and then x times that 5 is 5x. So I've multiplied this x by both terms over here. Now I'm going to multiply the 5 by both terms over here. So 5 times x would be another 5x, and 5 times 5 is 25, and then of course we still have the minus 33 in the end. So we combine like terms. 5x and 5x add to 10x, and 25 take away 33 is negative 8. So that is the same trinomial we started with, so that was correct. If this didn't expand out to the same thing, then probably an error here somewhere, although I suppose you could have this correct and make an algebra mistake down here too, I suppose. So that's the first example. So let's flip over to the second slide. And in this one, the main way that the second example is different from the first is the a value isn't 1 anymore. I've got a 4 here. So we're going to factor the 4 out of, 4 is the a value, out of the terms of the variable. Now, you don't factor it out of the 11. You actually could, but that actually makes it more complicated, so don't bother trying to factor. Even if that was something like 12 that 4 would factor it out easily, don't bother. Okay? So you only factor it out of the parts that have variables. So we're going to factor 4 out of 4x squared. So we would divide this by 4 to get just an x squared here. Now we're going to factor 4 out of the negative 24x. And this is what you do to find that value. So we're going to take that negative 24 and we're going to divide it by the 4 we're factoring out. And that works out to be negative 6. So we're going to be a negative 6x here. And then we close the bracket and write plus 11. So we factored the a value out of the terms of the variable. So the second part says to find the linear term coefficient and divide it by 2 and square it. So the linear term coefficient is this one, not the negative 24. Okay, it's the one we have inside the brackets here. So we take that negative 6 and divide it by 2 and square it. Now negative 6 divided by 2 is negative 3 that we're going to square, which of course is 9. So we're going to add and subtract that 9 here after the negative 6x inside the brackets. So it'll go right here, plus 9, and then subtract 9, and of course we still have the plus 11 out here. Now, so that's the second part. Okay, second step. Now the third step, remove the subtracted value, which is the negative 9, from the bracket. So that's going to come out, and we're going to multiply it by that 4. So the first 3 terms stay in here. That's going to be the perfect square trinomial we're going to factor in a moment. Negative 9 times 4 is negative 36. And then, so that's the third part here. Now the fourth step is to factor the perfect square and combine the like terms on the end. So so this would have to start with an x, and of course it's going to be minus 3 squared because that's the number here. Also half of negative 6 is a negative 3. And negative 36 and 11 add to negative 25. So that is the vertex form. That is the completing the square finished. And of course, we could expand this to, and we will get, and by like terms, we will get this trinomial up here. Okay, last example, and the way, actually 2 ways this one's different, is when we go to factor the negative 3, it's a negative 3 in front of the x squared here. It's negative, first of all. Okay, the coefficient, or sorry, the a value up here was positive. And also, 3 doesn't factor evenly in, or it isn't a multiple or a number that divides evenly into 7. Okay, so that's the other difference here. So first step is to factor the negative 3 out. Now, negative 3 factored out of negative 3x squared does leave us with an x squared here. And the way we find this value is we're going to take that 7 and divide it by negative 3. Just like I took the negative 24, and since I'm factoring 4 out, I divided it by 4 to get this negative 6x. So let me go back to my pen here again. So if I take that 7, I'm not going to bother write the x here. So because I'm factoring a negative 3 out, we're dividing it by negative 3. Okay, now there is an x here. So this is going to be negative 7/3 x. So that's how you find the term that is there if that coefficient doesn't factor evenly into. Okay, so it's going to look like this. Now, the next thing to do is to, in the last example, I just put brackets here. So a way you can make this a little bit shorter is kind of combining these 2 steps together. So instead of putting my bracket here and then rewriting the same thing with a space, you could actually move this bracket over here a ways and have the minus 8 after it. So this is where I'm going to do the add and subtract part. So we're going to add and subtract that half the linear term coefficient squared. So the linear term coefficient is the negative 7/3 x here. So I'm going to take the negative 7/3. Now, instead of dividing it by 2, I'm going to multiply it by half because it's a fraction. Dividing by 2, multiplying half is the same thing. So when you multiply negative 7/3 by a half, negative 7 in the numerator times 1 is negative 7, and 3 times 2 in the denominator is 6. So that's what we're squaring. Now, when you go to square that, negative 7 squared is positive 49. Remember, when you're squaring a negative, it's positive because a negative times a negative is positive. And in the denominator, 6 squared is 36. So that's the value we're going to add and subtract here. Okay. So I left my, so again, I'm combining these two lines, just leaving a space here after I do the factoring so that I can write that add and subtract part, okay, inside there. Now, so the next step is to bring this negative 49/36 out. Okay, so we're going to leave this inside here. So I'm doing step 3 here now. We're going to take this negative 49/36 out, and remember it's going to be multiplied by that negative 3. So let's do that multiplication over here. So negative 49/36 multiplied by negative 3. Negative 3 is the same as negative 3 over 1. And so when we multiply these, a negative times a negative is a positive. So this is going to actually be a positive value in this case. And the 3 here actually divides evenly into the denominator. So it goes in 12 times. Now, and so on the top, we've got 49 times. There's actually a 1 here, it's 49, and 12 times 1 is 12 in the denominator. Now, if you didn't notice that 3 divided in the denominator, 36. This is what you will do. Okay, so in the numerator, you might go negative 49 times the negative 3. So that's what's in your numerator now. And in the denominator, it has 36 times 1. So you'd have 147 over 36. And that actually reduces. So let's actually write that here. Whoops. 147 over 36, and 3 divides into those evenly. So if I divide that by 3, divide the denominator by 3, see 36 divided by 3, let's go back to my pointer here, is 12, and 147 divided by 3 is 49. If you want me to bring my calculator up just to show that, 147 divided by 3 is that 49. So when we bring this value out, multiplied by negative 3, it'll be a plus 49, and of course the 8 is still subtracted here. Okay, so that's the remove the subtracted value. Now the reason I've written the negative 8 is negative 8 over 1 is because we have two fractions here to combine. So we'll get to that in a second here. So we're going to factor the perfect square. So this would have to be x. Remember, it would be minus 7/6. Half of this coefficient, when you multiply negative 7/3 by a half, it's really just the same as multiplying the denominator by 2. So that's another reason why this is 6, and there's a negative 7 on top. Now, let's see here. So the coefficient, the negative 8 here, see there's a 1 in the denominator. So if I multiply this by 12, just to get the value in the end here, 12. Okay, so we've got 49 over 12. And 8 times 12 is 96, so minus 96 over 12. And 49 subtract 96. If you want to just see here, 49 subtract 96 is negative 47, so that's why that's minus 47 over 12. So that's the vertex form, complete the square form of this parabola. So those are the steps when completing the square. I've chosen, I think, 3 fairly encompassing examples from the most basic to this is, I mean, you could get more complicated if the fractions get bigger, but it really shouldn't get too much more complicated than this. So that's the idea behind completing the square, and that's the end of the tutorial.